Hello, I'm going to go ahead and go over numbers 13 through 25, and this is for the study guides, Common Assessment 3 Study Guide, Linear Functions. Alright, number 13, an airplane begins its descent descent means to go down at 39,500 feet. It descends 20 feet per second. The height of the airplane y after x seconds can be represented by the equation y equals negative 20x plus 39,500 feet. That makes sense because descending means it's going down. What does the slope and y-intercept represent? Okay, the slope represents the height of the airplane. The y-intercept represents the number of feet the airplane drops per second. No. This here is how much it's dropping, descending, so it's not A. The slope, which is m, represents, and this is written in slope-intercept form, the slope represents the number of feet the airplane drops per second. Okay, the y-intercept represents the height of the airplane at the end of its descent. Let's see. The number of feet the airplane drops, okay, that's true, because that's how much it's dropping per second. The y-intercept represents the height of the airplane at the end of its, not the end, it's at the beginning of its descent, so it's not that. The slope represents how long the airplane is in the air. No, it represents how much it's dropping. So I need to find something similar to this. So it's not this. Okay, it's probably this. The slope represents the number of feet the airplane drops per second. Okay, that's right. The y-intercept represents the height of the airplane at the beginning, and that is correct. 14. A line passes through the point 0, negative 2. Hey, that's my B. And the slope of the line is fine. What is the equation of the line in slope-intercept form? So this is my slope, or my y-intercept. So y equals, the slope is 5, so it's not that, and it's not that. Oh, wow, that was almost too easy. So it's this one, because, well, the only one was 5, and it makes sense that this is negative 2 because 0, negative 2 will always be your initial value because the x is 0, which is also the same as your y-intercept. Number 15. The equation 3x minus 2y equals negative 16 is written in standard form. Okay, I know you guys don't know what that word means. You actually learn more about that next year. But the point is, it's saying what is the equation written in slope-intercept form. So I just need to, rewrite it. So if it helps you, draw your line and write y equals mx plus b. And the y is already lined up. This negative 2 goes with that y, so I need to get rid of this 3x. And I get negative 2y equals negative 3x minus 16. Divide by negative 2, divide by negative 2, divide by negative 2. So then, I'm running out of room here, but y equals, this is positive, so 3 over 2x. And then this is positive, plus 16 divided by 2 is 8. So it's probably this one. This one, they flipped it, so that's not right. This one doesn't even have the proper fraction, so yeah, D is correct. Number 16, what is the equation of the graph on the right? Okay, I know a lot of you guys get this confused, and I understand that. This happens every year. But think about the where it crosses, which axis it's crossing. And it's crossing the y-axis at 2. I know it looks like the x-axis, but it's not. So let's not use the x's. It crosses the y-axis at positive 2, so the equation of that line is y equals 2. Number 17, what is the equation of the graph on the right? Okay, since we're looking for an equation, it's not about the slope. It's about what the equation on this line is. Since it crosses the x-axis, we're going to say x equals negative 4 because that's where it's crossing the x-axis. It doesn't cross the y-axis at all, so it can't be those. I know it's parallel to the y-axis, but that's not what you need to base your answer on. It's about where it crosses. What axis does it cross? Like here it crossed the y-axis. This one crossed the x-axis. Number 18, let's graph this. All right. Thankfully, it's already in slope-intercept form. Remember, you always start with your y-intercept, which is 3. There it is. And the slope here is negative 2. I'm going to put it over positive 1. So this is your change in y. This is your change in x. Remember, y only goes up and down. Change in x goes left and right. So since it's negative, it's telling you to go down. So I'm going to go down 2 and right 1. So 1, 2, right 1, 1, 2, right 1. And then if you want to go the opposite direction, you can go up 2, left 1, up 2, left 1, up 2, left 1. And it should make a line. And then you would hopefully have a straight edge of some sort, and you draw your line. And there it is. Okay, let's go to number 19. Number 19. Is this relationship linear or nonlinear? Okay, so this is where you need to look at every change in x and change in y. Don't get thrown off, okay? We gotta always look for change in x over change in y. So I don't like that there's so many values, but you know what? Such is life. So I'm gonna see change in y over change in x. Let's try this one. How did it go from, oh, by the way, these are your x's and this is your y's. If it helps you, just look at. So how did these y's change? We went from 2 to 5, you added 3. Okay, so you add 3. All the x's added 2. All right. How about this one? From here to here, you added 5. Here you added 2. That's looking interesting. Already, this is not linear, because if you look at this, 3 divided by 2 is 1.5, and 5 divided by 2 is 2.5. These are not equal. I'm just curious what the other ones turn out to be. Let's see, 10 to here, that's a positive 7. And then here it's 5, it's a positive 2. Yeah, that's also, so this is nonlinear. Nonlinear. They need to have the same change in y over change in x, so you look for that. Okay. Number 2, graph the equation. All right, it's already in slope-intercept form. I start with the b. This is your y-intercept, so down here. And this slope is telling me to go up 2, right 3, up 2, right 3. So up 2, right 3, up 2, right 3. And that's my line. All right, number 21. Is this relationship linear or nonlinear? Well, let's see. All right, so change in y over change in x, all of them need to be the same. So I'm going to look at all of these. How did it change? So this is my y's, and these are my x's. Okay, so be careful. How did it go from here to here? It went up 3, and here it went up 1, because to go from negative 3 to negative 1, you have to add, or negative 2. Watch what happens. 3 negative, add 1, and you're at negative 2. So you added 1 here. So which one's your change in y? This was your change in y. So 3 over 1. All right, well, let's check another one. This one's adding 3. This one's also adding 1. But see, don't say, oh, that's enough. You know, what if it changes right here at the end? So let's check all of them. 10, this is plus 3, and then this added 1 again. It's a good sign. Let's do it again. Plus 3, yep, plus 1. That's looking good. And then plus 3 again, and plus 1. Okay, and these all come out to be 3, 3, 3, 3, 3. Okay, so this is linear. Number 22, identify the slope and y-intercept of this line. It's already in slope-intercept form. That's almost too easy. The slope is 3, and the y-intercept is negative 1, or we write it as 0, comma, negative 1. I don't ever want you to forget that it's a y value. It's a point, so x has to be 0, and then there you go. And this is also your initial value, just as a reminder. 23. Carla has already written 10 pages of a novel. She plans to write 15 additional pages per month until she's finished. The number of pages for a novel is represented by this. Yeah, makes sense, because that's your rate of change, and that's your initial value, and that's, she started with 10, and she's adding 15 per month. What is the slope and y-intercept? Okay, that was almost too easy. It's already in slope-intercept form, and I'm going to write this as an ordered pair. Number 24, find the equation of the number of M&Ms eaten per hour. So it's going to be linear. So we need to find an initial value and the rate of change. If it's already linear, let's just pick 2 points, okay? So this will be your x, and this will be your y. We're not going to switch it up on you. Pick 2 points, okay? Now you can do like the arrows if you want. So I'll show both ways. Okay, I'll do it the long way, which is not that much long. Oh, look what I did. Yeah, that's not a y. These are your x's, and these are your y's. So x1 is here, but y1 is down here. They pair together. X2 and Y2. Okay, so let's see, we got X1, Y1, so that is, let's see, oh yeah, sorry, my brain I just checked out for a second. So let's do Y2 minus Y1 over X2 minus X1. And Y2 is 14 here, minus, see, I was going to go up there again. It's this one, minus 10. And then 4 minus 2. 14 minus 10 is 4, 4 minus 2 is 2, and then the slope looks like it's 2, the rate of change. Now some of you will be like, well, what if I do this? Miss Hong, this goes up 2, and this goes up 4. Excellent. So then which one is it? 4 divided by 2 is also 2. So the same. Okay, so that's my slope, okay, or rate of change. Now they don't give me an initial value, okay, but if I go backwards, I can find 0. So if it goes up by 2, let's go down by 2, it becomes 0. And then if it goes up by 4, let's go down by 4. So subtract 4 from 10, and you get 6. So your initial value is 6, and there's my equation. Number 25. Write 3 facts about the graph on the right. Obviously, there's a lot of facts here. You can say the slope is positive. You can say the y-intercept or initial value is 0, 0 because it goes through the y-axis at 0, 0. You can say the slope is, go up 1, right 2, this is your change in y, is 1/2. Another thing you can say is the line is increasing. Okay, what else can we say? You can say like 1, 2, 3, 4, -4, -2, -4, -2 is on the line. There's a lot of observations we can make about this. Okay, so those are a few. You only have to list 5 or 3, but hopefully I would be interested to hear what else you guys come up with. Okay.